let's solve the following problems. Compute the limit of the sequence that is n cubed plus 3 to the power n divided by 3 times m cubed plus 3 to the power n plus 3 as n tends to infinity. The first thing you have to notice in this sequence is that it's the exponential terms 3 to the power n and 3 to the power n plus 3 that will dominate the sequence as n tends to infinity. So we have to get rid of these terms by taking 3 to the power n up front, both in the numerator and in the denominator. And what it will leave us with is n cubed divided by 3 to the power n plus 1 in the numerator, and 3n cubed divided by 3 to the power n plus, well, here we'll have 27, because that's 3 cubed, 3 to the power 3, times 3 to the power n would give us 3 to the power n plus 3 back. So this is why we have 27 there. Now, of course, we can simplify with 3 to the power n, and we can simplify with a 3 here to get 3 to the power n minus 1. Nevertheless, both this term of n cubed divided by 3 to the n and this term n cubed divided by 3 to the n minus 1 will go to 0, well, will converge to 0 as n tends to infinity. So what we'll get is 0 plus 1 divided by 0 plus 27. This is because of the arithmetics of limits. We can take the limit of each individual term and we'll be left with 1/27. Next, decide whether the infinite sequence of summing -1 to the power k divided by the kth root of k, with k going from 1 to infinity, converges or diverges. So if you look at this sequence, and always when you are trying to establish the convergence of sequences, the first thing you want to do is apply the vanishing test. And that is to check whether the general term in the sequence, -1 to the power k divided by the kth root of k in this case, whether that general term will tend to 0 as k goes to infinity. If that's not the case, then the series fails the vanishing test, implying that it is a divergent series. So let's see what we'll get. Well, all we have to remember is that the limit of the kth root of k is equal to 1. And the limit of -1 to the power k as k goes to infinity does not exist. Okay, so this limit does not exist, so it's not equal, definitely not equal to 0. Hence, the series fails the vanishing test. Which, as we learned, implies that the series is divergent.